going to be talking about how to graph. So there's your title. There's kind of our purpose today. And we're going to talk about how to graph. Before you graph, you need to do a little bit of a review of A, B, and C. And let me give you an example problem. Let's say that we're going to take y equals negative x squared plus 6x minus 1. So it's a quadratic because of the x squared, which causes the parabola shape. And when you review your A, B, and C, there's kind of a 4-point checklist you run through. The first thing we're going to ask ourselves is this going to open up or down? Open up or down? And you figure that out by looking at the A value and also your notes too. Do you remember what happens when A is negative? Is it going to open up or is it going to open down? Down. A is negative, so this is going to open down. Okay. The second thing you want to ask then is your y-intercept. And this is nice because the C value is always the y-intercept. So it's the number that's on the end there, minus 1. The third thing you ask yourself is, did the parabola get shifted left or right, the vertex? So is there a shift left or right? And looking back at our notes, we could see that if A and B are both the same signs, then it would shift left. If A and B are opposites, they shift right. So I have a -1 and a +6. That tells me when we graph it, this is going to be shifted to the right. The y-intercept is going to be -1, and it's going to open down. If something there like doesn't happen on my graph, then I made a mistake, and I would have to find it and fix it. Okay. Now there's one more thing we'd ask, which would be number 4. And that is, what is the line of symmetry? The LOS is x equals -b/2a. And so what we want to ask ourselves is, what is the line of symmetry here on this graph that I'm looking at? And we have some values we can plug in. B is 6. So what I'm going to do is I'm going to go -6/2 times -1. So that's just going to be -6 divided by -2. What is that? 3. So my line of symmetry is x equals 3. You don't have to write out this check every time you do it, but this is the check that goes on in your head to make sure you graph it right. When you graph it, it should be centered around 3. It should open down. It should be shifted to the right. The y-intercept should be -1. All these things are true. Okay. Any questions so far? Okay, let's try to graph it then. Now, back when we were doing linear equations, you only need 2 points to make a graph, and it's a straight line. We know this is going to make a curved line, and so 2 points isn't going to be enough. There's kind of a debate around like how many points you actually need. The one that we find works best is the 5. If you have 5 points, you can make a nice curving shape. Okay, so that's what we want to do now, is we want to create 5 points that we could graph, and we do that by making a table. So let's make a table. Now, another way this is different than just a linear equation is there's a certain x value you have to use in your table, okay? And it has to deal with the shape of the line. And this is kind of why we did the activity on Monday, is this is going to be a curving shape, and it's going to be shifted. It's going to be around x equals 3. And what that means is everything that happened on one side is going to happen again on the other side. It's like a mirror image. And so I really want to make sure I graph that part of the quadratic. So my first value I'm going to use for my x is actually the line of symmetry. It's the 3. I'm going to take that and I'm going to put it kind of in the middle of my table here because I need 5 points. I'm going to use 3 for one of them. I'm going to use the x's 3 as one of them. And then I need to think, and I want to use a couple points that are to the left of it and a couple points that are to the right of it. And so if I go to the left of 3 on like a graph or on a number line, I would have a 2 and a 1. And if you go to the right, you're going to have a 4 and a 5. Okay, so it's important that you choose numbers like that based on where your line of symmetry is, because the line of symmetry is kind of your starting point. Does that make sense? Because it's the middle of the graph. And we don't know what the graph is yet, but it's going to be in the middle. Okay, so now we are ready to start to calculate some of our y values. What we're going to do is we're going to plug in these x values and see what comes out of our equation. Okay, and you know what? Let me write the equation here again, just so it's closer and I can find it. This is y equals negative x squared plus 6x plus or minus 1. I can't see it anymore on my paper, so I just wrote it again. So what we're going to do is we're going to plug in those x values and see what we get out of our equation. But again, I like to start with the middle value. You're going to start with the 3. So it's going to, everywhere I see the x in my equation, I'm going to plug in a 3. This is going to be negative, and we get 3 squared plus 6 parentheses 3 minus 1. Notice that that negative does not get squared. What the quadratic wants us to do is it wants us to square the 3 and then take whatever that answer is and make it negative. Okay, if the negative was inside the parentheses, then we'd have to square it, but it's not. So now I just do some math. 3 squared is 9, but it's actually negative 9 because of the negative. So I get negative 9 plus 18. Negative 9 plus 18 is 9. 9 minus 1 is 8. So when we plug in a 3, we get out an 8. And now we have to do it with the 2 or the 4. I like to go up and use the smaller numbers first. So let me replace all the x's with 2's. And it's going to look like that. The 2 now goes in the parentheses everywhere. And if you want, you can use a calculator or you can do mental math. It's really up to you. 2 squared is 4, but then the negative is going to make it negative. So I have negative 4 plus 12. That would be 8. 8 minus 1 is 7. So when x is 2, y is 7. And again, the whole point of this is we want to be able to accurately graph the parabolas. And now we're finding some points that are going to be on our line. And once we have 5 points, we can create a curving shape. So now we're going to plug in the 1 and see what we get out. So the 1 replaces all the x's. That'd be, let's see, 1 squared. So 1, but then plus 6, but it's negative. So negative 1 plus 6 is 5, minus 1 is 4. I believe we get a 4 when x is 1. Graphing parabolas takes a long time. You're going to be doing homework like this today. You're going to be trying this exact method that I'm showing you right now. Okay, we won't do too many graphs. We'll do just a good amount for you as some practice. Let's keep going. Let's try these 4s. We're going to replace all the x's with 4s. And one thing I see some students do sometimes that might be helpful is they actually write out all the equations before they solve them. So maybe we even want to like do the 5 and show where we're going to put the 5 in everywhere. That's another method you might use when you solve. So 4 times 4 is 16. Negative 16 plus 24 would be 8. 8 minus 1 is 7. Interesting. Let's do the other one. 25, but it's negative. Negative 25 plus 30 is 5. 5 minus 1 is 4. Huh. There are our values. What do you notice about the y values? Yeah, Ethan? So you notice that the LOS is at the 8, and then everything above mirrors everything below. Yeah, right? And that's what we would expect. If that didn't happen, then you made a mistake somewhere. Okay? So now when I go to graph it, I need to be strategic in my coordinate plane. Notice I don't have any negative values here. The largest my y goes up to is 8, and my x's are in between 1 and 5. So I'm thinking maybe my y coordinate might go all the way up to maybe like 10. We'll go a little above 8. So maybe up to 10. And then my x's maybe 5, maybe a little bit more. So I'm thinking I'm going to start from my y's. I'm going to start counting 10 down. So I'll graph it kind of right over here. I'm going to take my y values, and I need to leave room for 5 x's. So I'm going to kind of be off center a little bit. Right here, I'll start counting by 10, but from 10. So there's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then x's will go out 1, 2, 3, 4, 5. You know, maybe I even go like one more, just a little bit. Maybe I show the negatives a little bit too, kind of like that. So really my coordinate plane, I only have to worry about the positive quadrant. I don't have to do too much with the other ones. That happens a lot when you're trying to graph quadratics. Okay, so now I'm going to look through my table, and I'm going to take all my ordered pairs. And actually, it's nice to start with the LOS first, since that's going to be the middle. So when x is 3, y is 8. So I count over 1, 2, 3, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8, right there. And then when x is 2, y is 7. So over 2 up 7 will be right there. And when x is 1, y is 4. So up 1, 2, 3, 4, like that. So that's everything on one side, and then there should be everything on the other side too. When x is 4, y is 7. So that would be there. So it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Yep. And then 5 and 4. 1, 2, 3, 4, 5. Up 1, 2, 3, 4. There we go. We have some ordered pairs we can use now to create our graph. Now, when you graph these by hand, it's easy to accidentally make it into a V shape. These are never going to be V shapes. They're always curved. So here's my tip to you. Go to your line of symmetry, your vertex, and I'm going to make a curve shape right there so I don't accidentally make it a V. So I kind of do this. I kind of just draw like a little curve in there right there. Okay, and now we do our best to connect the dots, maintaining that kind of curved shape. So it curves down like this. And then this side curves down like this. There we go. We've graphed the quadratic. And it does everything we thought it would. It opens down. The y-intercept's at -1, so eventually this will cross down here somewhere. It was shifted to the right. Now, there are 2 more things you need to do in your graph, in your homework today before you're done. The first thing is you need to draw in your LOS. Your LOS is a dashed line that splits your parabola in half. And then we label it. The LOS was x equals 3. okay? And then you have the other piece you have to label is the vertex. The vertex is either the top of the curve or the bottom. In this case, it's the top. Our vertex was that point right there, which was 3, 8. So you label it 3, 8. Now you're done. Okay, so I don't know which method you like more. Do you like the accurate method like this to create your graph, or do you like the guess and checks that you were doing on Monday?
This one is more accurate.
Yeah. I find I kind of use a mix depending on which equation I'm dealing with. Sometimes you can guess and check really quickly and get it right. Other times you need to plug in some points and get your graph. Yeah. Yeah, this is definitely the most accurate way. Okay, let's do one more. Let's do it together. Let's make sure you guys got it before I give you the homework. I have a little bit of space on the bottom, but I'm not sure. I think I might run out of room. So I'm just going to flip my paper over for the next one, and we'll walk it through together. Okay. So again, we are working on graphing. So we are going to graph. And sometimes you might see the quadratics given like a function in function notation form, and it would look like this. F of x equals, and then here's our equation, 0.5 x squared plus 4. Remember, the f of x is the same as a y equals. You could even replace it if you wanted to. Basically, it's just saying that you're keeping track of what the inputs and the outputs. But that's what we use the table for. So what's the first thing we do? Can someone in person tell me what's the first thing we're going to do in the graph? The numbers. I see people turning back to look at what they did before. Good. What do you guys want to do first? Thoughts? Yeah. Yeah, do that checklist and it's really in our head that we do it. Okay, so let's run through the checklist. Is this going to open up or down? Up, because it's a positive 0.5. Okay, so it should open up when we graph it. Y-intercept, 4. It's missing the B term. There is no B term. So it's going to have a y-intercept of 4. It's not shifted since B is gone. That's what causes the shift that's not there. So it should be centered, should be at y-intercept of 4, opening up. Let's calculate the LOS. That's that last step. So the LOS was x equals negative b over 2a. Our b's missing though, so that means it's 0. So x is negative 0 over 2 times 0.5. Ooh, thanks, Cheyenne. I just saw your note in the chat there too. Yep. Yeah. So we always do the checklist first. Since the 0 is in the numerator, that just means our line of symmetry is x equals 0. Can someone online tell me what do we do now? What's your next step in graphing?
Make a table.
Make a table. Yep. Make your XY table. And we need to use the LOS to help us make the table. Okay, this is a big thing people forget sometimes. What did we do before? We did 1, 2, 3, 4, and 5. This time our LOS is at 0. So we're going to start with the 0 in the middle. Okay. And then we'll go to the left and to the right. So -1 and -2, and +1 and +2. Yes, thanks, Issa. Thanks, Griffin. Thanks, Cheyenne. And now we're going to find our y's. So everywhere we see an x, we're going to replace it with our number. And again, start with the LOS. So this is going to be 0.5 parentheses 0 squared plus 4. 0 times 0 is just 0. Times 0.5 is still 0. So y is 4. And then I like to go down always. I don't know, just because usually the smaller numbers are there. But you can go either way. We're going to go with -1s now. So everywhere I see an x, I'm replacing with a -1. Now this is interesting. Now the negative ended up in the parentheses because that's what our x value was. So that means it's going to be positive. So -1 times itself is 1. 1 times 0.5 is just 0.5 plus 4 would be 4.5. And now we do it again, but with the -2. -2 times itself is 4, plus 0.5 is 4.5. Wait, 4? No, sorry, it was multiplied. Oh, see, I was already starting to get it wrong. So it's 4 times 0.5. So that would be 2. And 2 plus 4 is 6. I believe. Did I make a mistake somewhere? I think that's okay. You know what? We'll know if I made a mistake when we go up and we do the other numbers too. I think it's okay though. I don't think there's a mistake there. Let's try with the 1 here. So 1 squared is 1 times 0.5 would be 0.5 plus 4 is 4.5. Okay, that was good. And now we'll do the 2. 2 squared is 4. 4 times a half is 2 plus 4 is 6. Hey, that looks good. I see that image. I see that mirror image repeating itself with our numbers. Now, let me point something out here. You have to use the 0 in your table because it's in the LOS, okay? Now, when we did the -1, we got this decimal number. You don't have to use -1. You just have to use numbers to the left. So if you wanted to, you could have done maybe like 0, -2, and I don't know, like -4 maybe, like trying to get like whole numbers just to make your life easier. And then same going up. So you don't always have to go by ones. You can change it to something else. If you're getting weird numbers, keep your life easy. So when we graph this, it looks like our y, maybe we want our y to go up to like 6, well, maybe a little bit more, like 7 or 8. And then our x's are only going to go from -2 to +2. So when I draw my coordinate plane, I think I'm going to start at 8 and count down. 8, 7, 6, 5, 4, 3, 2, 1, 0. Over 1, 2, maybe a couple extra. 3, 4, 1, 2, 3, 4. And then maybe go down a little bit on the y just to show the negatives. And then we graph the 0, 4 first. 1, 2, 3, 4, that'd be right there. That should be the vertex of our parabola. And our parabola should be opening up. When x is -1, y is 4.5, so put me right about there. And when x is -2, y is 6. So this would be 5 and 6, that'd be right there. Good, it looks like it's opening up. When x is 1, y is 4.5. When x is 2, y is 6. Yeah, that looks pretty good. Don't make it a V shape. Make sure you curve right at the vertex. And then you draw in and you connect your lines, like your dots, showing your parabola. questions, comments, concerns? We have to label the vertex and the LOS. The LOS is on the axis right here. So there's no point in drawing a dashed line in. Instead, we'll just label it up here. LOS was x equals 0. And our vertex in this time was down at the bottom of our parabola. It was a minimum amount. It was the lowest we went. So this would be the vertex. And its coordinate was 0, 4.